Hey guys, let's warm up with a couple of 2x2 systems of equations before we get back into our 3x3 systems. So for number one here, x is by itself, so I would substitute this in for x. So we're going to use the substitution method. So we've got 5 times 2y minus 5 minus 3y equals 24. Then we'll distribute this 5, 10y minus 25 minus 3y equals 24. Okay, I've got some like terms here. 10y minus 3y is 7y. And I can add this 25. 25 plus 24 is 49. And I'll divide by 7 and get y is 7. Okay, now I will plug that in right here for y. So 2 times 7 minus 5 equals x. So that's 14 minus 5, which is 9. So x is 9, so these two lines will intersect at the point 9, 7. And number 2, it doesn't look like a substitution kind of problem. I'm thinking because these have opposite signs, I'm just going to try to eliminate y's. I'll multiply this top equation by 5 and the bottom by 3. And that gives me 10x plus 15y equals 150. And 33x minus 15y equals negative 21. Okay, so the y's cancel, and I get 43x equals, and then 150 minus 121 is going to be 129. Okay, so I can pull out a calculator if I want to check that. So I've got 150 minus 21 is 129, and then divide by 43, and I get x equals 3. Okay, now I'll plug that into the top equation. So 2 times 3 plus 3y equals 30. Okay, so this is 6. So if I subtract 6 from both sides, I get 3y equals 24. And 24 divided by 3 is 8. So I get y equals 8. So the intersection of these two lines is at 3, 8.
Now elimination. So I want to eliminate a variable from a pair of equations and then eliminate the same variable from another pair of equations. So if I eliminate the x twice, I'm going to have two equations with a y and a z. I'll have two equations with two variables, and I'll continue solving as any 2x2 system. So the goal is once again to find a 2x2 system out of this 3x3. So I'm going to choose to eliminate x's because it just kind of looks easy. So I'm going to multiply this equation by negative 2. Okay, I'll rewrite it right up there. So negative 2x, and then positive 6y, negative 6z, and equals negative 4. And I'm going to combine those two equations. Okay, so the x's will cancel. 6y minus 4y is 2y. 5 and negative 6 makes negative 1, so minus z. And 7 and negative 4 makes 3. Okay, so I've got one equation down to a y and a z. I want another equation down to a y and a z. So I've got to eliminate x's from another pair of equations. I haven't used this bottom equation yet, so I have to now. And I can choose to use it with either of the two equations above. So let's just use the top one again. I'll multiply this by negative 2 and get negative 2x plus 10y minus 4z equals 6. Okay, so then I can combine that with the top equation. So if I combine those two equations, the x's will cancel. Negative 4 plus 10 is 6, so that's 6y. 5 minus 4 is 1, so that's plus z. And 7 plus 6 is 13. So I've got two equations now with a y and a z. And the z's are opposites. I've got a positive 1 and a negative 1. So if I combine those, I'll bring this one down. 2y minus z equals 3. So I just brought this one down here. I get 8y. Those cancel. Equals 16. So I divide and I get y equals 2. So I've got my first variable. I can plug that into any equation that just has a y and one other variable. So if I plug it in right here, 2 times 2 minus z equals 3. So I clear that up a little bit. Minus z equals 3. So that's 4 minus z equals 3. So I'm going to move that z over there to become positive. I'll move the 3 that way, and I'll get 4 minus 3 is 1, and equals z. I've got z equals 1. So I've got 2 of my variables. Okay, now I need to plug those two into whatever equation I want in order to get x. I will choose the middle equation. X minus 3 times y plus 3 times z equals 2. So that's x minus 6 plus 3 equals 2. Negative 6 plus 3 is negative 3. And I can add that 3 to the 2, and I get x equals 5. Okay? So I got that last answer by plugging into this equation. If you want to be sure that your answers are correct, you need to plug x, y, and z into the top equation, make sure they check out. Plug x, y, and z into the bottom equation, make sure they check out. It's possible that they could check out in one equation, but not all three. It's also possible that they could check out in two equations, but not all three. So it's important to be sure that these numbers check out in all equations. All right, in the next problem, I think it's going to be easiest to eliminate some z's. So I'm going to multiply this one by negative 1 and get negative x plus y minus z equals negative 1. And I'm going to combine that with the top equation. 2x minus x is x. Negative y plus y, oh, the y's actually just canceled. Z minus z, the z's also canceled. And negative 1 plus negative 1 is negative 2. So in trying to cancel the z's, I actually ended up canceling the y's and the z's. Okay? Now I'm going to try to cancel z's again. And since I've already multiplied this one by negative 1, I can eliminate here. So I'll just rewrite that down here. Negative x plus y minus z equals negative 1. So that's from multiplying this one by negative 1 again. And this time, it looks like the x's are going to eliminate. I'm going to get negative 2 plus 1, or negative 1y, or negative y. The z's eliminated, which is what I was trying to do. And 2 minus 1 is 1. So y equals negative 1. Okay, now I can plug that y and the x into any equation I want. I think the middle one looks easiest. So we've got negative 2 minus negative 1 plus z equals 1. So that's negative 2 minus negative 1 is negative 2 plus 1. Negative 1 plus z equals 1. And move that over. I get z equals 2. Okay, so these intersect at -2, -1, 2. All right, in the next one, looks to me like maybe eliminating the y's would be the easiest. So let's say I multiply this one by -2. And I'm just going to rewrite that above. So I've got 4x minus 2y minus 4z, and it equals -36. And I'm going to combine that with this middle equation. 3x and 4x makes 7x. 2y and -2y, those cancel. -3z and -4z makes -7z. And -36 and 1 makes -35. Okay, so I need to eliminate y's another time. So this time, how about multiplying this one by -2? And I'll get a -4y, which will cancel with this 4y. So I'll write that down here. -6x minus 4y plus 6z equals -2. So the y's cancel. 10 minus 6 is 4. -5 plus 1 is 1. Or plus 6 is 1. -3 minus 2 is -5. So I've got two equations, each with an x and a z. And it looks like eliminating the z's wouldn't be too difficult. If I multiply this one by 7, 28x plus 7z equals -35. And I'll bring this down under it. 7x minus 7z equals -35. So I get 35x, the z's cancel, and it equals -70. When I divide, I get x equals -2. All right, so I could use that maybe right here. 4x plus z equals -5. 4 times -2 plus z equals -5. So that's -8 plus z equals -5. And when I add that 8, I get z equals 3. The easiest equation to substitute into to get y is probably the top one. So -2x plus y plus 2z equals 18. And I should have actually substituted in there, and I didn't do it. So I need to go back and erase the x and the z and actually put those numbers in. -2 times -2 and 2 times 3. So that's 4 plus y plus 6 equals 18. And I need to subtract a 4 and a 6 from 18, so that's really subtracting 10. So I'm moving over the 6 and the 4. So 18 minus 6 is 12, minus 4 is 8. So these two lines intersect at the point -2, 8, 3. Okay, and our last problem. To me, it looks like eliminating z's is going to be probably the easiest, simply because it's ready for us to eliminate ones. There it goes again. Tip of the stylus got stuck. So I'm going to combine those. 6x. 4 minus 6 is -2y. And the z's cancel each other out. The 9's cancel each other out, so I get equals 0. Okay, then if I want to eliminate z's another time, Now I've got to do a little bit more work. I see the top has a negative z, the bottom has a positive, so I'll use these two. I'll multiply the top, since there's a 3 here, I'll multiply the top by 3, and there's a 2 here, I'll multiply the bottom by 2. So, across the top, 6x plus 12y minus 6z equals 27. And the bottom multiplied by 2, 2x minus 2y plus 6z equals negative 8. And my z's are going to eliminate. So I get 8x when I combine these. 12 minus 2 is 10. And 27 minus 8 is 19. So if I bring this one down here, I can eliminate the y's. I've got a positive and a negative. And if I multiply this 2 by 5, I'll get a negative 10. So I'm going to multiply by 5 as I bring it down. 30x minus 10y, so that's 6 times 5, and negative 2 times 5. And then 0 times 5 is 0. So the y's eliminate. I get 38x equals 19. And when I divide by 38, that simplifies to x equals 1/2. Okay? So the easiest place I think to substitute that is right here. So I'm going to put that 1/2 in for x. 6 times 1/2 minus 2y equals 0. So that 6 times 1/2 is 3. And I'll move that 3 over. So I'll get negative 2y equals negative 3. And divide by negative 2. Negative divided by negative is positive. And it's 3 over 2. Okay? So I've got this little bit of space left to work with. I've got an x and a y. I need a z. I think the easiest place to plug that in, probably the bottom equation. So that x is 1/2 minus the y is 3/2 plus 3z equals negative 4. Okay, so 1/2 minus 3/2. 1 minus 3 is negative 2, so it's negative 2/2, which is negative 1. So I can add that 1 over and get 3z equals negative 4 plus 1 is negative 3. Divide by 3, and I get z equals negative 1. So these lines intersect at the point 1/2, 3/2, negative 1.